In this video, we want to show that if R1 and R2 are the roots of a quadratic equation in standard form. So here's your equation in standard form: ax squared plus bx plus c equal to 0. If you add this, and then you have to show that if you add the two roots, that would be the same thing as minus b over a. If you multiply the two roots, remember the roots are just solutions. The product is c over a. Just introducing some basic theory here. You solve this equation here, ax squared plus bx plus c equals 0, using the method of completing the square. You will get the quadratic formula. So anytime you want to pause the video and see if you can show this, it's fairly easy. All you have to do is use the quadratic formula. And here we go. So here's your formula. X would equal to minus b plus or minus the square root of b squared minus 4ac. Of course, it's the b squared minus 4ac, that's your discriminant. We did some videos on that already, and that's over 2a. So one root will be given by using the plus sign, and the other root will be given by using the minus sign. So R1 plus the R2 equals 2. Okay, so here's R1, so we're going to add these up. We have plus the radical minus the radical. Obviously we have the same denominator 2a, so we can just add the numerators. So this part right here and this part right here, I got to cancel. I'm going to get minus b, and a minus b is a minus 2b. Over 2a. And the 2's are going to cancel out here. I'm left with minus b over a. And that's the first part. So this is saying if you take any two roots of a quadratic equation, the sum of those two roots will be minus b over a. Whatever the coefficient of the x is over the coefficient of the squared term, in this case a, and it'll be the negative of that. Now the product, R1 times R2. If you take the product of the two roots, now we just multiply these out. So notice it's minus b plus and minus b minus. So it's just like multiplying a minus b times a plus b. It's the difference of the squares of the first and the second term, so over the product of the, in this case, the denominator. So it's going to be minus b times minus b. That's going to be b squared. And on top it's going to be minus the radical times the radical. So that's going to be the same thing as squaring the radical, so that just eliminates the radical. Gives me b squared minus 4ac. And that's over 2a times 2a, so that's 4. A squared. And then this will equal 2, and what do we have here? B, and then we have b squared, then we minus all this, so this becomes a minus b squared and a plus 4ac. So the minus b squared and the b squared will cancel. Minus b squared, that cancel, and then a minus 4ac is a positive 4ac. That's over 4a squared. You can see the 4's will cancel out. A cancels one of the factors in the denominator, so on top we just have a c. At the bottom we have a. So we wanted to show that for any quadratic equation, the sum of the two roots, assuming we have the two roots, is going to equal to the negative of the coefficients b over a, and the product of the two roots will be whatever c is in the quadratic equation, the standard form, over the a. So this is basically saying if I have the equation, let's check it with one simple example. If I have the equation x squared minus x minus 6 equal to 0. This, you want to solve it by factoring. This is x minus 3, factor into x minus 3, and x plus 2. So once you have one side 0 and you have it factored out, we set each factor equal to 0. We get 1 root equals to 3, and the other root is equal to negative 2. So this is saying if I add the two roots, 3 plus 2, plus negative 2, this is equal to negative 1. And that should be the same thing as minus b over a. Right here, minus b over a. So the a is 1, the b is negative 1, and the c is negative 6, so this would be negative 1. Over a is 1. And this, of course, is plus here. 3 plus negative 2 is plus 1. And then over here we have minus and a minus times a minus is 1 over 1 equals to 1. That checks out. And then it says the product of the roots. So if I take 3 times negative 2, this of course is negative 6. And that's supposed to be the same thing as c over a. So in this case, c is negative 6. A is 1. So that comes out to negative 6. So we'll clear this out now. There's several applications you can have that the instructor can ask you. Let's look at one like this. Suppose you have this equation right here. Consider this equation, 15x squared minus 86x plus 119 equals to 0. So it tells you if one root is 7 over 3, find the second root, r2. And of course we could get it by factoring. You know, these are not large numbers, but the instructor can tell you, the instruction can say solve or get the second root using this result that we just went over. So according to one result here, then we know that the product of the roots is c over a. So c in this case is 119. And a is 15. And of course we know that one root is 7/3. So let me just replace the r1. Let's call that one the root that's given. Doesn't really matter how you set it up here. This is 7/3. So to solve the equation, then we just solve for r2. So we multiply both sides by 3 over 7 to isolate the r2. And this of course cancels out here. R2 then would equal to, here 3 divides out, and then 3 into 15 goes 3, 7 into 7 is 1, and 7 into 119 is 17. So the second root, using the result we just went over, is 17/3. If you were to solve this by factoring, then you would get 7/3 and 17/3. Now the other way you could do it, of course, is the sum of the roots. So you could say 7/3 plus R2 has to equal to minus B over A. So in this case, B is minus 86, so this would be minus that would give us 86. It's minus 86, but then negative of that, so that'll make this a plus here. Over A, and A is 15. And if you go ahead and subtract 7/3 from both sides here, 86 over 15. Minus the 7/3. You would get the same answer. Thanks for watching. We'll see you next time.